Hey guys, welcome to another video. So today we continue on with the good question series. Today's question comes from the advanced syllabus. Now, it's a really nice question actually, in the topic of functions transformation. So before I begin, as always, please like the video, subscribe to the channel and tell your friends. So guys, let's dive right into it. Today's question comes from North Sydney Girls 2023 past paper. Now, this question's nice because it's got two parts actually that are both quite, it's not as easy as it looks, but at the same time, once you sort of see it, it's not too bad. So let's go through it. So the diagram below shows two functions, f, x, and gx, right? Gx is a transformation of fx. Okay, cool. Now, you can see, right, that fx sort of looks like it's got two parts to this, like a kink there, while gx is also a kink going that way. Now, interestingly, right, I thought this question, let's read through it actually. List a sequence of transformations that we have to do. Okay, cool, right? I need to do transformations to get me from fx to gx, okay? And then if u equals to this, find the derivative. Oh, I thought that was real nice. And I'm quite excited about part B, but let's do part A first. Now, when you look at this question, right, what sort of jumps out at you is that there's a rectangle, right? The rectangle sitting right there. Rectangles are important because now we can sort of confirm that it's a rectangle, but visually it looks like a rectangle. Now, why is that important? Because rectangles, opposite sides are parallel, which means they have the same gradients, right? The gradient of these two is equal to the gradients of these. So the gradient of the two pinks are equal, and the gradient of the two greens are equal. That's important because when we transform something, I want to make fx look like gx by almost rotating it. It looks like it's a 180 rotation of sorts, right? Can you see that? Now, rotation isn't really a transformation that we use in the advanced syllabus. It is in 4-unit complex numbers for those that are curious, not in 2-unit. So the way we achieve the same sort of outcome is we sort of do a double sort of double flip, right? So a double reflection. So we reflect and we reflect to get the pink to look like, so to get the fx looking like gx. So this is how we're going to try to achieve it. Now, the best way I'm going to sort of do this, actually, I'm going to try something, right? I'm going to take a snip of this graph because I really want to operate this graph or try to explain this graph with a bit more space, right? And I'll show you what I mean by that. So I'm going to copy that there, extend the axis, right? Yep, that way, and also extend the axis that way, right? Now, what I want to achieve, and actually, before I do that, let me confirm that the gradients are the same. So, I mean, looking at the gradients here, it looks like it goes rise over run, right? It goes across 2 and up 1, right? And over here, across 2, up 1. Okay, perfect. So, gradients are the same. Yeah. And similarly, if I go with the other line, it goes, let's pick a point there, goes down 3, across 1. And if I pick any point there, down 3, across 1. Yep, perfect. Gradients are the same. Cool. Which means I can conclude, right, this guy is parallel to this guy, and this guy is parallel to this guy. Perfect, right? Now, let's transform. So guys, remember, if I start off with the function of y equals to fx, right, as my original, right? If I immediately put a minus in front, right, that would reflect the graph downstairs below the x-axis, right? Yeah, it reflected about the x-axis. So it takes this coordinate of 6, 4. If I apply this step, it brings it back down here, right, to -6, right? So I'm not doing it to scale, but basically it'll bring it downstairs looking like that, okay? Is that all right? So let's see if that makes sense. Oop, that doesn't make sense. Right now, this guy flipped downstairs. That's got a 6 like that. Well, this is sort of still coming like that, right? That's step 1. Yeah, that's step 1 though. I'm sort of getting it there. Now, so once I flip it downstairs, I now need to sort of flip it across the y-axis or reflect it across the y-axis as well. And to achieve that, right, I basically put a negative inside where the x is, right? Inside where the x is, and that will bring it all the way over from, right now, the corner here is at 4, -6. It brings it to like -4, -6. But the moment you do that, right? Because if you sort of picture it, where it sort of has a intercept at -6, it sort of makes it look like the same shape as GX, right? Can you see that, right? Because right now, what I've done with the double flip, it almost acts like a 90-degree rotation, right? Where the gradient of this is now similar to the gradient of GX. The gradient of this is similar to the gradient of GX over here, right? I've got the shape. Now I just need to move it, right? I need to translate that shape into where GX is, right? So, and the way I do that, right? I want to move now, let's see, I'm all the way down here. I want the corner to be over here. Let's see what I do. I need to move it now up by 6, and I need to move it to the right by, what is that? That's 4 units here, and 3 units here by 7. So, right, up 6, right 7, and I'll get the corner exactly to land on that spot, right? So it looks like I'll go y equals to negative. Now, by the way, it tells you to list the transformations. I'm doing the equation. I'm just showing you extra steps, right? But I'll put it into descriptions of transformations after I do this. So I want to add 7 to get, add 6 rather, to get the vertical translation happening. And then, guys, be careful here. Now, once again, you don't need the formula, but if you wanted to horizontally translate to the right, remember where the x is, right? Where the x is, that's where the action happens. So I go x minus 7, right? So you just got to make sure the negative's out there so it doesn't impact your reflection, right? So that's the equation that I want, right? That final equation. The question didn't ask for the equation. We gave the equation as extra information, but hopefully you see what I'm trying to do. And it's such a nice question because I reflected it downstairs below the x-axis, reflected it to the left, right, about the y-axis. And once I knew that the shape was there, it's all about just translating it into place. So if you had to describe, so for part A, right, if you had to describe the transformations, right, there are 4. Now, how many marks is this, by the way? 3 marks, full transformations. I don't know how they give marks for that, but here you go. So I'll start off with what I did there. So I'm going to horizontally reflect. So vertically reflect about the x-axis, horizontally reflect about the y first, right? So I'll go vertical reflection about x-axis. Yeah. Horizontal reflection about y-axis, right? That's the double flip. Yeah, and then shift up, shift left, also shift right. So I'll go vertical translation. Now, for those that are like, how come you didn't do all of it? You can't do all of the verticals together and do horizontal, but it doesn't matter, right? Because they commute, right? Yeah. So vertical translation, upwards by how many units? 6 units. Yep. And then horizontal translation to the right by 7 units. Yeah. So I thought that was a good, I mean, it is a great question. I really liked it because it's not obvious how you get that 90-degree rotation as a transformation, but that's how you do it. Yeah. Now, can I just say the question gets a little bit better. I really like question B, right? I'll make a copy of this slide, go to the next one, and we'll explore it, right? So that's part A, done. Let's have a gander at part B. All right. Part B says, let ux equal to that. Find the derivative at 1. Now, if we just blindly went algebraic on this, right? I know that's product rule, right? Product rule UV. So where U dash would be, well, F dash X and V dash is, well, g dash x. So if I wanted to find an expression for its derivative, right? Because that's what I want, right? It'll be u dash v, so f dash x gx plus v dash u, so g dash x fx. And because they want, the question says, I want you to sub in the value of 1 into where the x is, right? So u dash 1 equals to subbing 1, replace all the x's with 1s. Yeah, now this is cool. So remember, every time we have a dash, that is the gradient, right? Yeah, gradient of fx at x equals 1. And similarly, this guy is gradient of gx at x equals 1. And every time we have just the function itself, well, that's just saying when x equals 1, what's y equal to, right? Same thing with this, x equals 1, what's y equal to? Yeah, so that's just the y value. So we get all that from the graph. Now, at x equals 1, just to be absolutely clear, right? Where is that? So just lining it all up, I'll use a different color. It's basically everything that happens on this line, right? So let's say 0, 1, yep, on this line here. Yeah, we get all our information from here. So for example, right, at this, I'm just going to zoom right in, guys, if that's okay. Yep, zoom right in. So at this coordinate here, right, on the G, on fx, what color did I use? Doesn't matter. For fx, right? Yeah, for fx, maybe I'll just highlight that there, right? If I explore this guy over here, right, when x equals to 1, the value, right? The value there, now let's see, looks like, is that 4.5, right? Because 5, yeah. When x equals to 1, the y value, maybe I'll just replace it with the fx, right? Fx value equals to 4.5. Maybe I'll go 4.5, yeah. And the gradient, now, what is that gradient over here, right? The gradient looks to be rise over run. Gradient looks to be 2, right? The gradient is 2. Yeah, in other words, f dash x, right? F dash x is 2. Okay, cool. I've got all the information that I need for the f function. Now, let's do the same for the g function, right? So at this coordinate here, right, I'll pop up here, when x equals to 1, gx, well, maybe I'll go g of 1, right? So maybe I'll replace the letters just so I can sub it in directly, right? Yeah, g of 1 equals to 6, I can see that, and its gradient. Now, what's the gradient here? So if I did rise over run again, that looks to be -3, right? Right, run across 1, -3. Yep, perfect. -3. Guys, I now have all the necessary ingredients, right, to sub into this. So I'm going to go f dash x, also f dash 1 is 2, g1 is 6, g dash 1 is -3, and f1 is 4.5. Is that all right? So that looks like it's 12 minus, what's that, 13.5? No, is it 12? Sorry, I subbed in the wrong number. F dash 1. Oh, careful, guys. The gradient isn't 2, is it? It's half, right? Is it actually, if I did that right, run across, yeah, sorry, my bad. So that's a half there. So just pop that in. And so F dash 1. So F dash 1 is this one. And that's a half. That's 3. And then the final answer, -10.5. Really nice question, right? Really nice question because it, not, so the transformation one, I really liked it because it was a 90-degree rotation, right? Which isn't common, right? And then part B, it's product rule, and it really makes you understand or draws out your understanding of, what does it mean for a derivative on a straight line graph, which is the gradient of straight line, and also the function itself, which is just the y value. Guys, that's the question. If you like that, please subscribe to the channel, like the video, and tell your friends. Thank you very much.